Hello guys, so can you solve this JAMB indicial equation? Now in this equation, we have been told to find the value of P, Q and what R in this equation. Now, if we study this equation, we'll find out that it will be very hard for us to get the values of P, Q and R by solving for them directly. Okay, so what we're going to do here is that we can get the values of P, Q and R only by comparison, direct comparison. What that means is that we're going to try as much as possible to make this left hand side look exactly like the right hand side. Then by direct comparison, we're going to get the values of P, Q, and R. So the only thing we're going to do here now is just that we're going to try to simplify this. Okay, simplify the numerator, the denominator, join them together and make them look exactly like this. Then we'll compare their powers and get the values of what we want. Okay, so let's start by simplifying the numerator. We're going to use different laws of indices that we've learned before to simplify. So how can we simplify here now? Now we know that this power is affecting these three bases, okay? Because this bracket means this power belongs to these three different bases, okay? So what we're going to do first of all is that we're going to split the power for the different bases, okay? For A, B, and C, we're going to share the power for them, okay? So we're going to have here now, we're going to have A to the power of 2, all to the power of 3 over 4. Then we have B to the power of negative 3, all to the power of 3 over 4. Then we have C. Then we C have the power of 1, all to the power of 3 over 4, all divided by A to the power of negative 1, B to the power of 4, C to the power of 5 equals A, P, B, Q, C, R. Yes. So we're getting there bit by bit. So now what are we now going to do here? We're going to use another law of indices to simplify this. Now, we have the power of the power. Now, going to the law of indices, whenever you have the power of the power like this, you're going to multiply, not add, okay? We're going to multiply the two powers. So we're going to apply that law here to simplify this further. So we're going to have A to the power of 2 times 3 over 4. Since it's a fraction, you can say 2 here 1, 2 in 4, 2. So we'll be left with 3 over 2. Then B to the power of negative 3 times 3 gives us 9, negative 9 all over 4. Then C, 1 times 3 over 4 gives us 3 over 4 all over. Now this denominator we can't simplify because it have different bases. The bases are not the same. So there's nothing we can do to simplify that. So we're going to rewrite it just like the way it is. C to the power of 5 equals, same as these two can be simplified. Just write it the way it is. Now we are getting close bit by bit. So what are we going to do here next? There is no fraction here. We have a fraction here. Don't forget, our aim is to make it look exactly the same, make them look the same. So we have to eradicate this division by simplifying. And how do we do that? Don't forget the law of indices also. When we are dividing the same base, okay, when we are dividing the same base, we subtract their power. When we are dividing, we subtract the power. So we're going to divide these two. That's we're going to pick 1A, one base. Then we have 3 over 2 minus negative 1. We pick 1B. Then we have negative 9 over 4 minus 4. Then we pick 1C. We have 3 over 4 minus equals A to the power of P, B, Q, C to the power of R. Okay, so let's simplify this. Now we're going to have A to the power of, now we have 3 over 2 minus negative 1. That will give us 3 over 2 plus 1. So we have to add these two together, right? Let us use a shortcut. We want an equivalent denominator, so we'll add directly, multiply up and down by 2. So we have 2 over 2 here. So we'll be left with 5 over 2. So this gives us 5 over 2. Then B to the power of, here also we have negative 9 over 4 minus 4. Equivalent denominator also, we have 16 over 4. So negative 9 minus 16 gives us negative 25 all over 4. So here we have negative 25 all over 4. Then C to the power of, same thing also. To have equivalence, we're going to have 4 times 5, which is what? 20 all over 4. So here we're going to have 3 minus 20, that's negative 17 all over 4. So here we have negative 17 all over 4. Yes, we are almost done. And please, if you make it this far, don't forget to subscribe to my channel, please, to learn a lot of mathematical stuff like this, to have a lot of mathematical insight, and also to learn some tricks like this if you don't know about them before. Okay, and as a way of supporting me also, way of supporting my channel. Let's go further. So here now, we have gotten our final answer here because this have we have made this to look exactly like this. So by direct comparison, now we can get the value of PQ and R. Why? Because now we have the same base, A and A, equal base. Therefore, P must be equals to 5 over 2. Same thing to B, the same base. So B2, that's Q, the power must be the same. Q must be equals to negative 25 over 4. And lastly, since we have CC, the same base, therefore R, the power must be the same, negative 17 over 4. Final answer. Very, very what? Simple. If you learned something here, please subscribe to my channel for more. Now, till next time, if you have a question, please drop it in the comment section. Or you have a similar question to this that you want us to work with, drop it in the comment section, okay? So till I come your way next time, bye.